Okay, so welcome to this part of the exam 2 review for AWC's General Chemistry 1 or Chem 151 Supplemental Instruction session. This is the area that we didn't cover yesterday, and so I just want to go over this with you. The first question that we have states that we have dissolved 200 grams of lithium permanganate in 4.7 liters of solvent with a density of 330 milligrams per centiliter, and we've called this solution A. Then the question begins with, if the saturation point of solution A occurs at 0.3 molarity, that's moles per liter, is the solution saturated, unsaturated, or supersaturated? If the solution is unsaturated, find out how many grams are needed to make the solution saturated. If the solution is already supersaturated, find out how many grams there are in excess. Assume that the density of lithium permanganate is 2.1 grams per milliliter. So the first thing that we need to know is what is saturated, unsaturated, or supersaturated. When a given solution, a saturated solution, will have that amount of grams dissolved in that amount of milliliters, or that's what we often work in, or that amount of mass dissolved in a certain amount of volume, and that'll be our solution at its perfect level, the maximum amount of solute you can dissolve in a solution and in a solvent and come out with your solution. If it's unsaturated, you haven't put in that maximum amount. If it's supersaturated, you put in over it. If you had a solubility curve, you would see where the line is, and at that certain temperature, because it does change with temperature, you would see that if you plotted it on that line, that would be saturated. If it's above it, it's supersaturated. If it's below it, it's unsaturated. So the first thing that we need to do is we need to get this information and put it into molarity so that we can compare them. So the first thing that we'll do is we'll look at lithium permanganate. Well, lithium permanganate is LiMnO4 because lithium is Li plus and permanganate is MnO4 minus. By adding the mass numbers of all of these, remembering to multiply that one by 4, we would find that the molar mass is equal to 125.88 grams per mole. Now the next thing we'll use is we'll convert this into moles so we can find molarity. But what I always like to show is that if you're going from grams to moles, or moles to atoms, molecules, or ions, that for grams to moles we use molar mass. For moles to atoms, molecules, or ions, this is Avogadro's number, which is equal to 6.022 times 10 to the 23rd. If we're in a balanced chemical reaction, we can use moles to moles, and we'll use the molar coefficient. So following that line of thought, we're going between moles to grams, so we're still going to use molar mass, or grams to moles actually. And so we'll have 200 grams of lithium, and I'm just going to write it over here so you know that's the unit I'm working in, but so that I don't have to keep writing it over here, I'm just identifying it as this. On a quiz or exam, you may want to actually write in grams of lithium permanganate. And now we'll multiply this times the molar mass, putting grams on bottom so that they'll cancel each other out. And so if we do that, so that's 200 divided by 125.88, we get 1.58 moles. All right, let me, I don't know, 200 divided by 125.88. Yeah, 1.58 moles. Okay, so we're good there. Now what we want to do is let's come down here and use this. And so we know how many moles we have. Let's now divide it by our volume, because molarity is equal to moles solute by liter solution, my abbreviation for solution, SLN. And so let's take that information. We have 1.58 moles, and this is for lithium permanganate, and we'll divide it by 4.7 liters, our volume of solvent. What we get is about 0.338, depending on how you round, which is also equal to 0.338 capital M moles per liter. So we'll compare that with the molarity that we have up here for the saturation point of solution A, and we see that's 0.3 molarity. So that means that because this number is above this one, this is supersaturated. So now let's answer this. How many grams are there in excess? Well, we can simply subtract the molarity here, because this is just moles per liter. So if we subtract 0.338 molarity minus 0.3 molarity, we get 0.038 molarity. I'm just going to write it out, molarity. And so we'll take that, so 0.038 moles per liter, and we'll multiply this. And we can drop the liter as we go on, but we'll multiply this because it's per that 1 liter that we have, so we don't actually need to write this in here. So we just dropped it right now. And then we'll multiply this by the molar mass, because we're still up, now we're going moles to grams. 125.88 grams over 1 mole. This is again of lithium permanganate. Our moles will cancel each other out. And the answer that we'll get is 4.78344 grams in excess. So here are our two answers. Supersaturated, and this is how many grams are in excess. Now, and this needs to say solution A. Okay. If we poured 750 milliliters of solution A into a beaker and left it uncovered until only a solid remained, what would the mass in milligrams of the solid be? Well, I'm going to give you some time to think about this. If we left it uncovered until only a solid remained, what moles will we be looking at? Because this is still lithium permanganate. We're looking at this, 1.58 or 1.589 moles. So we actually haven't really done anything because we've poured, so we don't need to worry about changing our molar mass because we know it's still lithium permanganate. But what we did sort of change is that we now only have 750 milliliters of that original 4.7 liters in our solution. So I'm going to set this up as a ratio. You don't have to, but I think it makes visual sense if we do it that way. So what I'm going to say is, in the original 4.7 liters, we had 1.58, and I'm going to go with 1.589 moles of LiMNO4, and we had 4.7 liters. We now know that we have 750 milliliters. If we convert that to liters, it's 0.750 liters, and we can cross multiply, and so that would be like our x. So what we're doing is we're multiplying 1.589 times 0.750 and dividing by 4.7 liters, and what we'll get is 0.25 moles have remained in there of LiMNO4. So we'll take that information and we'll say 0.25 moles LiMNO4. We can use our same molar mass because we haven't changed the identity of the chemical. So again, 125.88 grams up on top, 1 mole on the bottom, so it'll cancel each other out. This is again of LiMNO4. We'll multiply 0.25 times 125.88, and our answer is 31.47 grams of lithium permanganate, LiMNO4. Well, we can't stop there because it's asked for in milligrams. I'm asking for in milligrams. Excuse me. So if we'll take that, we'll multiply 31.47 grams lithium permanganate times 1 gram on the bottom, 1,000 milligrams on the top. That's our ratio that we're using to convert. And what we get is 31,470 milligrams LiMNO4, lithium permanganate. Now let's say this is very like in a lab, what might happen in a lab. If we poured the solid into 100 milliliters of water, what would the concentration of the new solution be? Well, because I'm going to say right now I want this in parts per billion. where parts per billion is micrograms per liter. If it had been parts per million, it would have been milligrams per liter. If it had been molarity, it would have again been moles per liter. But I'm going to say let's do it in parts per billion. So we've got to convert that into micrograms. So we'll say we've got 31,470 milligrams. And again, this is lithium permanganate. But for the sake of time and space, I'm not going to write it out on every single one, although that is the most correct way to do it. And then we're going to say in 1 milligram, we have 1,000 micrograms. So our answer then is 31470,000 micrograms. 31,470,000 micrograms. And then we'll divide it by a liter. So let's convert 100 sonoliters into 1 liter. What would that be? Well, 100. I'm just going to write it off sort of up at the top here. Sonoliters times, we want sonoliters on the bottom, 1 liter on top. So that's the one we'll get it in. There are 100 sonoliters in a liter. So it's just 1 liter. Divide that by that. And so then you get 31,470,000 parts per billion, which is the same thing as micrograms per liter. And then finally, a little bit of chemical reactions and stoichiometry. If we carried out a double displacement reaction and added 250 milliliters of solution B, this is now solution B, so we're not looking at solution A up here, but this solution B, and then added excess of nickel 3 sulfide, nickel 3, we have that Roman numeral because it's a transition metal, to the same beaker, what is the maximum theoretical yield in milligrams of the lithium-containing product? So let's write out what the equation would look like. We know what LiMnO4 is, so we've got lithium permanganate. Then we're going to add that to nickel 3 sulfide, so that's Ni2S3. And then that reacts, because this is a double displacement, there's our cation, there's our anion, there's our cation, there's our anion. Lithium reacts with sulfur. And nickel reacts with permanganate. So that's NiMnO. We've got 3 of those. So if we balance our chemical equation out, let's add 2 over here. We could start with adding 2, but that might cause more issues with here. So I'm going to say let's start with nickel. So we'll put a 2 in front of nickel. Now that's balanced out. Now for the sulfur, let's add a 3. But now we've got 6 of the permanganate. Okay, so let's add a 6 over here. And we also have 6 of the lithium. There's a chemical reaction. So let's start out with, and if we're looking for the product, the lithium-containing product, that's this one. And we know this is a solution B, so we have 31,470 milligrams of this, which is equal to 31.47 grams. Okay, so we'll take that and we'll say, but we have to remember that we only did 250 milliliters of this, and this is grams per liter of what we had here. And so then we'll multiply this times our, actually I'd rather not multiply, I'm going to set up a ratio of our 0.250 liters and then cross multiply. So that's 31.47 times 0.25, and we divide it by that by 1, so we get 7.8675 grams is what is in our new solution. Now that we've added 250 milliliters of this to this beaker that has excess nickel 3 sulfide, so let's convert this to moles. And so we'll say, let me just 7.8675 grams. This is still lithium permanganate, so we can multiply it to them. So that's the same molar mass we've been using the whole time, 125.88 grams over 1 mole. And our answer then is 0.0625 moles. So following this, if we're going to go in between moles, which we need to do to first to be able to find grams, milligrams of the lithium-containing product, we use our mole coefficient. So let's do that down here. 0.0625 moles times, this is, and now it is important to write it in LiMnO4, 6 moles LiMnO4 and we're trying to get the lithium-containing product, 3Li2S, lithium sulfide. And our answer then is 0.03125 moles. Okay, and then to do that, we would need, now to convert this into milligrams, we need to find the molar mass of lithium sulfide. I'm going to let you do that and then convert it, but I want to let you know that the answer is 574 milligrams. So you can check your answer with that. Okay, this is converted to milligrams after finding molar mass. Okay. And then solving it out. So that's the end of this page.